So, okay, right. Okay, slowly, slowly. Right. Li Ying, you read the question. This one, number 8. The diagram
The
above.
above
The above
the
diagram.
above diagram
Hmm.
shows a curve y equal to 4 over x and the straight line y equal to negative 2x plus 6. Calculate the volume generated when the shaded region in the above diagram is revolved through 360 degrees about the x-axis.
Okay, right. Now, probably in the diagram given in the question is very small, so you cannot see clearly what is happening. So I draw the curve again, y equals to 4 over x, the curve of this part. Then I draw the straight line, y equals to 2x, negative 2x plus 6. Okay. Wow. Okay, right. Okay. So this shaded part here, the part that is shaded blue here, okay, I show you. Yes. The part that is shaded blue here, I color it again this way. Now, this part that is shaded actually consists of two parts. One part is under the line here, under the curve, and another part is under the straight line. Can you see that the shaded part consists of two areas? Yes or no? One part is one part is under the curve, another part is under the straight line. So it consists of two parts.
Yes.
Okay, right. So if we are going to find the volume generated, you have to find them separately because if you want to integrate by y square dx, you can only find out this white color part. The green color part is under the straight line. Of course, you can integrate the straight line, but I'm not going to integrate the straight line because I know that this straight line, when you revolve it 360 degrees, you actually get a cone, right? So I'm going to use the formula for the cone to find out. I'm going to use the formula for the cone to find out this area. I'm not going to integrate, okay? So only this part I'm going to integrate. But before you know how to integrate, you must know the 3 points here. The point of intersection between the curve and the straight line, A and B, and the point of intersection between the curve and the x-axis, which is C. So if you know the coordinates of A, B, and C, then you will know the limit, the upper limit and lower limit of the definite integral. And if you know B and C, you will also know the dimensions of the cone. Which one is the radius? Which one is the height of the cone? Right? Okay. Ayo, yo, yo. Okay. Supposed to take this away. Okay. So where am I going to put it? Put it here. Okay, right. So now, continue. Where to continue? Is it here? No. Is it this one? Oh, yeah, this is correct. Okay. So now I'm going to show you how to find the coordinates of A, B, and C. Okay, we are going to find the coordinates of A, B, and C. So first of all, I copy down the equation of the straight line. Equation of the straight line is y equals to negative 2x plus 6. Okay, next one. Next one is the equation of the curve. Equation of the curve is y equals to 4 over x. So I have to solve equation 1 and equation 2 to find out the 2 points A and B, the points of intersection between the straight line and the curve. Okay, so I join up the two equations. Negative 2x plus 6 equals to 4 over x. How to solve this equation? You multiply by x. Every term you multiply by x. So you will end up having a quadratic equation. So when you multiply by x, negative 2x squared. Multiply by x, you have 6x. Multiply by x, you have 4. Now this quadratic equation, actually the negative, the x squared is negative, and also there is a common factor 2 in each term. So I might as well divide by negative 2. Divide by negative 2, you have x squared. Divide by negative 2, you have negative 3x. So divide by negative 2. The 4 divided by negative 2 is negative 2. Negative 2 you bring over to the other side, it becomes positive 2. So this quadratic equation is x squared minus 3x plus 2. And this equation can be easily factorized. So after factorizing, you have two numbers. You have two numbers of the coordinate of x. The first one is x equals to 1. And you try to substitute into equation 2 to find out the value of y. So it is 1, 4. Which one is 1, 4? A or B? 1, 4. A. A. Then I substitute, this will give me x equals to 2. I use x equals to 2, I substitute into equation 2. So 4 divided by 2 is 2. So 2, 2 is which point? 2, 2 is the point B. 2, 2 is the point B. Okay, next. So the point A is 1, 4 and the point B is 2, 2. Now, I want to find the point C. To find the point C, I have to use the equation of the straight line. Okay, the equation 1. Equation 1. What should I substitute in? I have to substitute in y equals to 0 because along the x-axis, y equals to 0. So when I put y equals to 0 into equation 1, or the equation of the straight line, I have negative 2x plus 6 equals to 0. So what is the value of x? X is 3. So the coordinate of C is 3, 0. 3, 0. Okay, so far, any question?
No, teacher.
No. So far, what we have been doing is finding out the coordinates of A, B, and C. A, B, and C to know the upper limit, lower limit, and the dimensions of the cone. Okay, right. Okay, let me show you this cone here, right? This is the cone. Which is the cone? Here. So this area, I copy down at the bottom here, right? I copy down at the bottom, and the first part between A and B, between A and B is this part here, right? I can find by integration. The second part between B and C, which is a straight line. Now when I rotate this straight line, I will get a cone here. This green part is a cone, right? And the cone is between 2 and 3, right? Between 2 and 3. The volume generated by the curve is between 1 and 2. Okay, right. So if the required volume, that means that the total volume here, the required volume is the volume generated by the curve plus the volume generated by the straight line. So which one is the volume generated by the curve? Which one is the volume generated by the straight line? Okay, volume generated by the curve is this part here, right? This part here. Okay, volume generated by the straight line is this part. Is this part here. Okay, this is the part. Okay, now the volume generated by the cone is still volume generated by the curve is still volume generated by the curve, Our volume generated by the straight line is a cone. This is a cone, right? This is a cone like that with a round base. So volume of the cone. Now, there is another way to find out the volume generated by the cone. So, you can always, volume generated by the curve, you can integrate by y squared dx, and the volume generated by the straight line is also by y squared dx, but the y is the y for the straight line. The y for the straight line, this one, negative 2x plus 6 square. Oh, this is quite difficult because you want to integrate this again and substitute numbers again. This is quite difficult. So I tell you, oh, you can always use integrate by y squared dx, which is the y which comes from the curve. This y comes from the curve. This one comes from the curve. Then instead of integrating the straight line, right, I just use the formula for the cone. Okay, so the first step, you can use by y squared dx for the curve, by y squared dx for the straight line. But I'm going to do it the easy way, by y squared dx for the curve, and for the straight line, I use the formula for the cone, right? I use the formula for the cone. So how are we going to do? Next step. Okay. Okay, next step. Right. So pi y squared dx. Now pi y squared dx for the curve, the limit is from 1 to 2. The limit is from 1 to 2. And this is the curve. The limit is from 1 to 2. So this is correct, right? And when I replace the y with 4 over x, I have to put y squared. So 4 square is 16. X square is x to the power of 2. This is correct. Then we come to the volume of the cone, 1/3 by r square h. What is the 1/3 by r square h? Now, this line here, from 2 to 3, is the height of the cone. Then this line here, until B, from 2 to B here, this is the radius of the cone. The radius of the cone comes from the point B. The radius of the cone comes from the point B. And B is how much? 2, 2. So that means this height here is actually, the radius is actually 2. Okay, so the radius is 2, become pi r square is 2 square, and the height of the cone is 1, from 2 to 3. So the height is 1. So this is the formula. So far, okay, can follow? Okay, can follow or not? The part which is under the curve is the first part. The part which is under the straight line is the cone. I don't want to integrate the straight line. I just use the formula for the cone. Okay, so if it's okay, then we continue. I remove this line first. Okay, I remove this line. Okay, continue. Next. Okay, so integrate 16 over x squared is negative 16 over x. Okay, this one. 16 over x squared is negative 16 over x. Okay, and the upper limit 2, lower limit is 1. And the volume of the cone, when you multiply out everything, 4 over 3 pi. So this is the volume of the cone. So when you substitute in 2, is because of the negative in front, the first term become negative, right? The second term become positive because you subtract a negative term. So the second term become negative, become positive, right? So it's 16 over 1 and plus 4 over 3. Lastly, the answer is you use your calculator, 9 and 1/3 unit cube.